Good afternoon, everyone. So today we will continue. We do our exercise 7.10 on theory 7.10, where we discuss the some specific property of definite integral, which by using of that property we can simplify the definite integral and find the values directly. There are total 7 property, and we use any of them to simplify the definite integral. So question number 1 is, by using the property of definite integral, evaluate the integral from 0 to pi by 2 cos square x dx. So now we need to find the value of definite integral from 0 to pi by 2 cos square x dx. We can directly evaluate it without using any property if you can. So at first we find the value of antiderivative, and then using the second fundamental theorem of integral calculus, just apply the limit, lower and upper limit, and find the value of definite integral. But can we use any of the 7 property so that this integral converted into a easier form where we find the definite integral comparatively easier than direct method? So at first you try. So answer is pi by 4. Let the given integral be I. So I is equal to definite integral from 0 to pi by 2 cos square x dx. Consider it as equation number 1. Now we will use the property of definite integral 0 to a fx dx is equal to 0 to a f a minus x dx. This is the most powerful property of definite integral, and generally it will be used in trigonometric function like cos function and sine function. It converted our definite integral into a simpler function that we can integrate easily. So because the cos and sine function are symmetric in nature, so you use the property of that, where when we integrate a function from a different from a to a fx dx is become integration from a 0 to a f a minus x dx. So in this case, a is equal to pi by 2 and fx is equal to cos square x. So when we find the value of f a minus x, just replace x by a minus x, that is pi by 2 minus x, and we know cos pi by 2 minus x is sin x. So cos square pi by 2 minus x become sin square x. So apply the property to the integral. My integral become 0 to a, that is 0 to pi by 2 f a minus x, that is sin square x dx. Okay, consider it as equation number 2. Now we have two equation with I. First one is I is equal to 0 to pi by 2 cos square x dx, and second one is I is equal to 0 to pi by 2 sin square x dx. Can we use this both equation to find the value of I directly without even integrate the function cos square x? So if we combine equation 1 and 2, we get I plus I is equal to 0 to pi by 2 cos square x dx plus 0 to pi by 2 sin square x dx. So we get 2i is equal to 0 to pi by 2 cos square x plus sin square x dx. And by the fundamental trigonometric identity, we know that sin square x plus cos square x is 1. So my integral become 2i is equal to 0 to pi by 2 1 dx. So now we need to integrate 0 to pi by 2 1 dx. In question, we have to integrate from 0 to pi by 2 cos square x dx. But using that property with trigonometric identity, we convert our problem to just to integrate 0 to pi by 2 1 dx. And that is the importance of our properties. Understand? So when we integrate 1 dx, we get x. So 2i is equal to x. So now we apply the second fundamental theorem of integral calculus. Apply the limits. So at first, take upper limit minus lower limit. We get pi by 2 minus 0. That is 2i is equal to pi by 2. So I is equal to pi by 2 by 2. That is pi by 4. And that is the value of definite integral. So by using the property 0 to a fx dx, integration of 0 to fx dx is equal to 0 to a f a minus x dx, and with a trigonometric identity cos square x plus sin square x is equal to 1, we convert the definite integral from 0 to pi by 2 cos square x dx into just now we need to integrate 0 to pi by 2 1 dx. Okay. Question number 2 is, now we have to find the value of definite integral 0 to pi by 2 root under sin x by root under sin x plus root under cos x dx. So just think which property we should apply. So whenever there is a in question there is a trigonometric function, so we can apply the property number 5, that is 0 to a fx, integration 0 to a fx dx is equal to 0 to a f a minus x dx, because sine and cos functions are symmetric in nature, so we can apply that property. So just try. So answer is pi by 4. So let's consider I is equal to 0 to pi by 2, integration 0 to pi by 2 root under sin x by root under sin x plus root under cos x dx. Consider it as equation number 1. So now we use the property of definite integral 0 to a fx dx is equal to integral 0 to a f a minus x dx. So here a is equal to pi by 2 and fx is equal to root under sin x by root under sin x plus root under cos x. So f a minus x is equal to f pi by 2 minus x. So we get root under sin pi by 2 minus x by root under sin pi by 2 minus x plus root under cos pi by 2 minus x. And we know sin pi by 2 minus x is cos x and cos pi by 2 minus x is sin x. So f pi by 2 minus x become root under cos x by root under cos x plus root under sin x dx. And that is your equation number 2. Now we have two equation with I. So can we use this two equation to find the value of integral? So if we the equation number 1 is 0 to pi by 2 root under sin x by root under sin x plus root under cos x, and equation 2 is 0 to pi by 2 root under cos x by root under cos x plus root under sin x dx. So clearly we can observe that when we combine this both integral, it become 0 to pi by 2 root under sin x by root under sin x plus root cos x dx plus 0 to pi by 2 root cos x by root cos x plus root under sin x dx. So we can say denominator are same, and because the limit are also same, we can combine this both equation. We get root under sin x plus root under cos x by root under sin x plus root under cos x. Now numerator and denominator are same, so we can cancel out. So we get 2i is equal to 0 to pi by 2 1 dx. So when we apply that property, the my indefinite integral quotient become, just now we need to integrate 0 to pi by 2 1 dx. Because sine and cos are symmetric in nature, so whenever there is a quotient involving sine and cos, we can apply the property number 5. Okay, so 2i is equal to 0 to pi by 2 1 dx. So now integrate 1 with respect to x, we get 2i is equal to integration of 1 dx is x, and pi by 2 is upper limit and 0 is lower limit. So apply the limit of integration. So 2i is equal to pi by 2 upper limit minus lower limit. So 2i is equal to pi by 2. When we simplify for I, we get I is equal to pi by 4, and that is the value of your definite integral. Okay. So now question number 3 is, now we need to find the value of integration from 0 to pi by 2 sine the power 3 by 2 x dx by sine the power 3 by 2 x plus cos the power 3 by 2 x. Now here there is also sine and cos function, so we can apply the property 0 to a fx, integration 0 to a fx dx is equal to 0 to a f a minus x dx. Okay, so just try. So answer is pi by 4. Let's consider it as I is equal to 0 to pi by 2 sine the power 3 by 2x by sine the power 3 by 2x plus cos the power 3 by 2x dx. Consider it as equation number 1. Now we need to integrate this. So to integrate, we use the property that 0 to a fx dx is equal to 0 to a f a minus x dx. In this case, a is equal to pi by 2 and fx is equal to sine the power 3 by 2x by sine the power 3 by 2x plus cos the power 3 by 2x. So when we find the value of f a minus x, that is f pi by 2 minus x, my expression become, since sine pi by 2 minus x is cos x and cos pi by 2 minus x sin x, we get cos power 3 by 2x by cos the power 3 by 2x plus sine the power 3 by 2x dx. Okay, and so we get another equation for I, and let's consider it as equation number 2. Now we need to find the value of I, and we have two equation for I, so just use this both equation to simplify your expression and find the value of integral. So we can see for both equation the denominator is same, and when we combine the both equation, so just add equation 1 and equation 2, we can add because limit are same. Always remember, we can add the integrals, two different integral, only if the limit are same. So the limit is 0 to pi by 2 in first, and in second also 0 to pi by 2. So it become 0 to pi by 2, as denominator are same, we can combine the numerators. It becomes sine the power 3 by 2x plus cos the power 3 by 2x by sine the power 3 by 2x plus cos the power 3 by 2x dx. Now numerator and denominator same, so just cancel out. We get 2i is equal to integration of 0 to pi by 2 1 dx. Integrate 1 with respect to x, we get 2i is equal to x 0 to pi by 2. Apply the limit of integration, we get 2i is equal to pi by 2. 2i is equal to pi by 2. So I is equal to pi by 4. So in this all three question, we apply that property, and we can see by using using the trigonometric identity, the sine square plus cos square just become 1. And in this question, the numerator and denominator, when we apply that property, we get two equation involving I, and when we add both equation, we just left with integration of 0 to pi by 2 1 dx. Okay. Now, next question is, find the value of definite integral from 0 to pi by 2 cos the power 5x dx by sin the power 5x plus cos the power 5x. So just try. So answer is again pi by 4. Let's consider it be I. Let the given integral be I. So I is equal to 0 to pi by 2 cos the power 5x by sin the power 5x plus cos the power 5x dx. Consider it as equation number 1. So now we will use the property of definite integral. 0 to a fx dx is equal to 0 to a f a minus x dx. Here a is equal to pi by 2 and fx is equal to cos the power 5x by sin the power 5x plus cos the power 5x. Okay. So we need to calculate f a minus x. Just put in place of x pi by 2 minus x. So we get f a minus x, that is f pi by 2 minus x is equal to cos the power 5 pi by 2 minus x by sin the power 5 pi by 2 minus x plus cos the power 5 pi by 2 minus x. And as we know, cos pi by 2 minus x is sin x and sin pi by 2 minus x is cos x. So I is equal to 0 to pi by 2 sin the power 5x by cos the power 5x plus sin the power 5x dx. And that is your equation number 2. So now we have two equation with I. Just in the similar way, we add equation 1 and 2. We get I plus I is equal to 0 to pi by 2 cos the power 5x by sin the power 5x plus cos the power 5x dx plus 0 to pi by 2 sin the power 5x by cos the power 5x plus sin the power 5x dx. In both cases, denominator are same, limit are same, so we can combine. We get 2y is equal to 0 to pi by 2. Now we can see clearly that denominator and numerator are same, so it can be cancelled out, and we get 2y is equal to 0 to pi by 2 1 dx. So just integrate 1 with respect to x. We get 2y is equal to x 0 to pi by 2. Same as previous questions. So apply the limit of integration. 2y is equal to pi by 2 minus 0. So 2y is equal to pi by 2. So I is equal to pi by 4, and that is the value of definite integral. Okay. Now, question number 5 is, we need to find the value of definite integral from minus 5 to 5 mod x plus 2 dx. Okay. So in this question, we need to integrate mod x plus 2, and we know we cannot directly integrate mod x plus 2. We have to remove mod sign to integrate it, and when we remove the mod sign, it either positive or negative according to the function is positive or negative on that interval. So at first we have to find at which interval x plus 2 is positive and or negative, and then according to that interval we have to integrate it. So just try. So answer is 29. If you remember, I already mentioned that the value of definite integral, when we calculate definite integral, the value is always a numerical value, and when we calculate indefinite integral, the value is always a function, because we can relate a definite integral with area function, and area is a numerical value. Okay, so let's consider it as I is equal to minus 5 to 5 mod x plus 2 dx as absolute value function. Mod x plus 2 change its definition based on the sign of x plus 2. X plus 2 is positive or negative. According to that, the absolute value function changes. Okay, so at first we have to find the value of critical point. So what is critical point? Critical point are the points, from that point the values are either positive or negative. For example, in this question, if x plus 2 is equal to 0, to find the critical point we just take x plus 2 is equal to 0. So x is equal to minus 2, so minus 2 is a critical point. It means that from minus 5 to minus 2 the sign are same, and then from minus 2 to 5 the sign are changed, because to change the sign of any function x plus 2, it need to cross the x-axis, and the critical points are the points where the function value x plus 2 is 0, and on that point the function changes its sign. Okay, so if x plus 2 is greater than 0, that is x is greater than minus 2, then mod x plus 2 is equal to x plus 2, because x plus 2 is positive when if x is greater than minus 2. It means when we take an interval from minus 2 to 5, the function value, the absolute value function x plus 2 gives x plus 2. Similarly, x plus 2 is negative, x plus 2 is less than 0, if and only if that is x is less than minus 2, then the absolute value function gives minus x plus 2, because on the interval below than minus 2 the absolute value function is minus x plus 2. Okay, so according to the critical point we split the integral into two parts. First part is minus 5 to minus 2, and then minus 2 to 5, because in this both interval the absolute value function gives two different functions. First one is x plus 2 and second one is minus x plus 2. Okay, and we have a special property, that is, by using this property we can split the integrals into subintervals. If we have to integrate a function from a to b fx dx, that is we need to integrate on interval a to b, we can split the interval from a to c and c to b. So to find the value of definite integral from a to b fx dx, now we just need to calculate the value of definite integral on the subintervals and combine them to get the value of definite integral on entire interval. Okay, here the value of a is minus 5, b is 5 and c is minus 2. We split the interval from the critical point, at a critical point. Okay, so the integral become I is equal to minus 5 to minus 2, and here the value of absolute value function is minus x plus 2 and minus 2 to 5. and here the value of absolute function is x plus 2 dx. Now integrate each part. For the first integral, minus 5 to minus 2 minus x plus 2 dx, it become minus 5 to minus 2 x plus 2 dx is equal to minus, then x square by 2 plus 2x. Upper limit is minus 2 and lower limit is minus 5. We use the property of formula, that is integral of xn is x to the power n plus 1 by n plus 1. So we calculate the value of antiderivative. So now we apply the second fundamental theorem of integral calculus. Just apply the limits. At first, substitute the upper limit at the value of antiderivative function minus lower limit. So we get minus square bracket 4 by 2 minus 4 minus 25 by 2 minus 10. So when we simplify, we get 9 by 2. Okay. Now for the second integral, minus 2 to 5 x plus 2 dx, it become x square by 2. Integration of x is x square by 2 and integration of 2 is 2x. Upper limit is 5 and lower limit is minus 2. So apply the limits. In place of x, at first put 5, then minus, and then the value of lower limit. Just put the value of lower limit. So we get 5 square by 2 plus 2 into 5 minus 2 whole square by 2 plus 2 into minus 2. So when we simplify, we get 49 by 2. Just simple calculation. Now add the result of both integral. So I is equal to 9 by 2 plus 49 by 2. So it become 58 by 2. The value of definite integral is 29. Okay. So whenever there is a question involving absolute value function, so at first we have to split the intervals according to the sign of function involving absolute value. If the sign is positive on that interval, we take that interval, then negative one, and then if there is any other interval on there is a positive or negative. But we have to calculate in different intervals according to the sign and then combine all the values to get the value of definite integral on entire intervals. Okay. Now question number 6 is, we need to find the value of definite integral from 2 to 8 mod x minus 5 dx. On a similar way, at first we have to find the critical point and then the interval where the function sign is positive or negative. Okay, try. So answer is 9. Now the given integral be I. So I is equal to integral 2 to 8 mod x minus 5 dx. So as the value changes its definition based on the sign of x minus 5. So at first we need to find the critical point, and to find the critical point we just take it as x minus 5 equal to 0. So x is equal to 5 and 5 is a critical point. So we need to split the interval from 5. Now take if x minus 5 is greater than 0, then x is greater than equal to 5. So in that interval, greater than, when x is greater than 5, the value of absolute value x minus 5 is x minus 5. So on the interval 5 to 8, mod x minus 5 is x minus 5. And if x minus 5 is negative, that is less than 0, then x is less than 5. And on that interval less than 5, we take x minus mod x minus 5 is minus x minus 5. So on the interval 2 to 5, the value of mod x minus 5 is minus x minus 5. So the interval of integration 2 to 8 includes the critical point x equal to 5. We need to split the integral into two parts using the property a to b fx dx is equal to a to c fx dx plus c to b fx dx. Here a is 2, b is 8 and the critical point is 5. So the integral become divide into two parts. First one from 2 to 5, and here the value of absolute value function is minus x minus 5, and from 5 to 8, here the value is positive, so x minus 5 dx. Now integrate each part. For the first integral, from 2 to 5 minus x minus 5 dx, it become minus x square by 2 minus 5x. Lower limit is 2, upper limit is 5. So apply the second fundamental theorem of integral calculus. Just apply the limits. We get minus 5 square by 2 minus 5 into 5 minus 2 square by 2 minus 5 into 2. So it become, just do the simple calculation. So the value of first integral is 9 by 2. Now for the second integral, 5 to 8 x minus 5 dx is x square by 2 minus 5x. Upper limit is 8 and lower limit is 5. So apply the limits on the value on the function antiderivative. What is the function antiderivative is x square by 2 minus 5x. So just take upper limit 8 square by 2 minus 5 into 8 minus the value of function of antiderivative at lower limit, that is 5 square by 2 minus 5 into 5. So we get 64 by 2 minus 40 minus 25 by 2 by 25. 64 by 2, that is 32 minus 40, and 25 minus 50 by 2. So it become minus 8 minus 25 by 2. So just do a calculation and we get the value of second integral is 9 by 2. So add the result of both integrals. First is 9 by 2 and second is also 9 by 2. So 9 by 2 plus 9 by 2, it becomes 18 by 2, and that is 9. Therefore the value of integral is 9. Question number 7 is, now we need to evaluate the integral from 0 to 1 x into 1 minus x whole power n dx. To integrate this interval, there is we need to calculate 1 minus x whole power n. So just try. So answer is 1 by n plus 1 into n plus 2. Let the given integral be I is equal to 0 to 1 x into 1 minus x whole power n dx. So when we need to when we integrate this when we need to integrate the equation 0 to 1 x into 1 minus x whole power n, we use the property of definite integral 0 to a fx dx is equal to 0 to a f a minus x dx. Here a is equal to 1 and fx is equal to x into 1 minus x whole power n. So f a minus x is f 1 minus x and become 1 minus x into 1 minus x whole power n. Simplify 1 minus x, it become 1 minus 1 plus x. 1 cancel out, so it become x. So the integral I become 0 to 1 f a minus x, that is 1 minus x into x the power n. So substitute back for f I minus x. So f 1 minus x is equal to 1 minus x into x the power n. Apply the property to the integral. So I is equal to 0 to 1 minus x into x the power n dx. And now this is easily integrable than the expression 0 to 1 x into 1 minus x the whole power n dx. Okay, so by using that property we convert our definite integral into a simpler form which can be easily integrable. So expand the integrand, multiply with x the power n, which become x the power n minus x into x the power n dx. So 0 to 1 x the power n minus x the power n plus 1 dx. So now integrate each term using the power rule, that is integration of xk is x k plus 1 by k plus 1. So I is equal to xn plus 1 by n plus 1 minus xn plus 2 by n plus 2. Now apply the limits. So just take upper limit, so 1 the power n plus 1 by n plus 1 minus 1 by 1 the power n plus 2 by n plus 2 minus 0 the power n plus 1 by n plus 1 minus 0 the power n plus 2 by n plus 2. In the second part, the term involving 0, so it become I is equal to 1 by n plus 1 minus n plus 2. So when we simplify it, find a common denominator which is n plus 1 into n plus 2. So I is equal to n plus 2 minus n plus 1 by n plus 1 into n plus 2. So just break it, we get n plus 2 minus n minus 1 by n plus 1 n plus 2. N is cancel out, so it become n 2 minus 1 is 1. So I is equal to 1 by n plus 1 into n plus 2. And that is the value of definite integral. So when we use the property, that is the integration of 0 to a fx dx is equal to 0 to a f a minus x dx, the definite integral from 0 to 1 x into 1 minus x the power n, it converted to a problem which is easily integrable than the original problem. Okay. So the next question is evaluate the integral from 0 to pi by 4 log 1 plus 10x dx. So just try. So answer is pi by 8 log 2. Let's consider I is equal to 0 to pi by 4, integral 0 to pi by 4 log 1 plus 10x dx. Consider it as equation number 1. Now we will use the property, famous property. 0 to a fx is equal to 0 to a f a minus x dx. Here a is equal to pi by 4 and fx is equal to log 1 plus 10x. So when we apply, we find the value of f a minus x. So f pi by 4 minus x, so it become log 1 plus 10 pi by 4 minus x. Using the trigonometric identity, 10a minus b is 10a minus 10b by 1 plus 10a into 10b. Here a is pi by 4 and b is x. So it becomes 10 pi by 4 minus 10x by 1 plus 10 pi by 4 into 10x. The value of 10 pi by 4 is 1. So it becomes 1 minus 10x by 1 plus 10x. Substitute this back into the expression for f pi by 4 minus x. So when we apply the property of definite integral, we get another expression for I, that is I is equal to 0 to pi by 4 log 1 plus 1 minus 10x by 1 plus 10x dx. Now we simplify it more. So just simplify the term inside the logarithmic. So 1 plus 1 minus 10x by 1 plus 10x. It become 1 plus 10x plus 1 minus 10x by 1 plus 10x. So we get 1 plus 10x plus 1 minus 10x by 1 plus 10x. 10x is cancelled out. It become 1 plus 1, that is 2. 2 by 1 plus 10x. Substitute this simplified term back into the integral for I. So now we get another expression for I, that is I is equal to 0 to pi by 4 log 2 by 1 plus 10x dx. Now we apply the logarithmic property, that is log a by b is equal to log a minus log b. So log 2 by 1 plus 10x become log 2 minus log 1 plus 10x dx. So we get, distribute the integral sign, we get 0 to pi by 4 log 2 dx minus 0 to pi by 4 log 1 plus 10x dx. When we observe, the second term on the right side is original integral I. So just put it as I. So I is equal to 0 to pi by 4 log 2 dx minus I. And we need to calculate the value of I. And we have an expression, that is I plus I is equal to 0 to pi by 4 log 2 dx. So 2I is equal to 0 to pi by 4 log 2 dx. Since log 2 is constant, we can integrate it as 2I is equal to log 2 into x 0 to pi by 4. So my question of calculate the definite integral from 0 to pi by 4 log 1 plus 10x dx, by using that property, it become to calculate the integral from 0 to pi by 4 log 2 dx. So just apply the limits. So 2I is equal to log 2 into pi by 4 minus log 2 into 0. So it become pi 4 log 2. So finally solve for I, we get the value of I as pi by 8 log 2, and that is the value of definite integral from 0 to pi by 4 log 1 plus 10x dx. Okay. Now question number 9 is evaluate the integral from 0 to pi by 2 x under root 2 minus x dx. So try this question. So answer is 16 root 2 by 15. Let the given integral be I. So I is equal to 0 to 2 x into root under 2 minus x dx. So we can simplify this, we can find the value of definite integral by using the substitution method, or we can apply the property of definite integral so that it converted to a easier form. So when we apply the property, that is 0 to a fx dx is equal to 0 to a f a minus x dx. Here the value of a is 2 and the function fx is equal to x into root under 2 minus x. Applying the property, we replace x with 2 minus x. So f 2 minus x is equal to 2 minus x root under 2 minus 2 minus x. So it becomes 2 minus x root under 2 minus 2 plus x. 2 cancel out. One is with positive sign with a negative sign. So it becomes 2 minus x under root x. Now substitute this back into the integral for I. So I become 0 to 2 minus x under root x dx. Now integrating this 0 to 2 minus x under root x dx, it's much easier than integrating the 0 to 2 x under root 2 minus x. Okay. So just distribute root x, that is x to the power 1 by 2. We get I is equal to 0 to 2 into x to the power 1 by 2 minus x into x to the power 1 by 2 dx. So I is equal to 0 to 2 into x to the power 1 by 2 minus x to the power 1 plus 1 by 2. So it becomes 0 to 2 into x to the power 1 by 2 minus x to the power 3 by 2 dx. Integrate term by term using the power rule for integration, that is integration of xn is x to the power n plus 1 by n plus 1. So it becomes 2 into x to the power 1 by 2 plus 1 by 1 by 2 plus 1 minus x to the power 3 by 2 plus 1 by 3 by 2 plus 1. Upper limit is 2 and lower limit is 0. So when we simplify, we get 4 by 3 into x to the power 3 by 2 minus 2 by 5 into x to the power 5 by 2. So finally apply the limit of integration. Upper limit is 2 and lower limit is 0. So in place of x, at first put 2 and then minus and then 0. When x is equal to 0, both term become 0. So we only need to evaluate it, the value upper limit. So it become I is equal to 4 by 3 into 2 to the power 3 by 2 minus 2 by 5 into 2 to the power 5 by 2, and the second term is become 0. So now this we have to simplify the power of 2. So we need to calculate 2 to the power 3 by 2. So when we need to calculate the fraction power of 2, we know the property of that x to the power a plus b is x to the power a into x to the power b. So we can write 3 by 2 as 1 plus 1 by 2. So it becomes 2 into 2 to the power 1 into 2 to the power 1 by 2. That is 2 root 2. And 2 to the power 5 by 2 as 5 by 2 can be written as 2 plus 1 by 2. So it becomes 2 to the power 2 into 2 to the power 1 by 2. And that is 4 root 2. So substitute these values. We get I is equal to 4 by 3 into 2 root 2 minus 2 by 5 into 4 root 2. When we simplify, we get 8 root 2 by 3 minus 8 root 2 by 5. Now combine this term, find a common denominator, that is 15. So it becomes 40 root 2 by 15 minus 24 root 2 by 15. That is 16 root 2 by 15. And that is the value of definite integral. So in this question, by using the property of definite integral, we convert this integration into an easier form. We can integrate 0 to x under root 2 minus x. But by using the property, we just change it into an integration that is more easier than the original question. Okay. Now, question number 10 is evaluate the integral 0 to pi by 2 2 log sin x minus log sin 2x dx. Just try. So answer is pi by 2 log 1 by 2. Given integral b, let the given integral be I. So I is equal to 0 to pi by 2. 2 log sin x minus log sin 2x dx. Let's simplify the integrand using trigonometric and logarithmic identity. As we know, sin 2x is 2 sin x cos x, and log ab is log a plus log b. So at first, substitute sin 2x in the integral. So it becomes log 2 sin x into cos x. And as log ab is log a plus b, so log 2 sin x cos x is log 2 plus log sin x plus log cos x. So it becomes 2 log sin x minus log cos x minus log 2 dx. So I is equal to 0 to pi by 2 log sin x minus log cos x minus log 2 dx. Consider it as equation number 1. Now we need to integrate this to find the value of definite integral, and that is difficult. So we use that property of definite integral so that we get another equation for I. We use the property of 0 to a f x dx is 0 to a f a minus x dx. In this case, a is equal to pi by 2, fx is equal to log sin x minus log cos x minus log 2. So applying the property, we replace x with pi by 2 minus x. So f pi by 2 minus x is log sin pi by 2 minus x minus log cos pi by 2 minus x log 2. As we know, sin pi by 2 minus x is cos x and cos pi by 2 minus x is sin x. So it becomes 0 to pi by 2 log cos x minus log sin x minus log 2 dx. And this is equation number 2. Now we have two equations with I. So when we add equation 1 and equation 2, we get I plus 1, that is 0 to pi by 2 log sin x minus log cos x minus log 2 plus log cos x minus log sin x minus log 2 dx. That is 0 to pi by 2 log sin x minus log cos x minus log 2. We can clearly observe here that there is a term log sin x and one term with negative log sin x. Then log cos x with positive and also with negative. And then two term with minus log 2. So log sin x cancel with minus log sin x and minus log cos x cancel with log cos x. So 2i is equal to 0 to pi by 2 minus log 2 minus log 2 dx. So it becomes 0 to pi by 2 minus 2 log 2 dx. As minus 2 log 2 is constant, so we just need to integrate 0 to pi by 2 1 dx. So when we integrate 1 dx, we get x. Just apply the limit of integration. We get 2i is equal to minus 2 log 2 pi by 2 minus 0. And that is 2i is equal to minus 2 log 2 pi by 2. So 2 cancel out, it becomes minus pi log 2. Finally solve for I, we get I is equal to minus pi by 2 log 2. Using the logarithmic property, that is a log b is equal to log b a. So pi by 2 minus log 2, that is pi by 2 log to the power minus 1, and to the power minus 1 is 1 by 2. So the final answer is pi by 2 log 1 by 2. So we use the property of, in this question we use the property that is integration of 0 to a fx dx is 0 to a f a minus x dx. And by using that property, we get two equations with I, and when we combine the both equation, some terms are cancel out and we just get a easier form of integration. Okay. Okay,